2.7. Use absolute value functions in transformations. Vocabulary. Absolute value function is a function in the form f of x equals the absolute value of x. Remember, f of x is just another way to write y. So it can also look like that. And that's the parent function of an absolute value function. You can have a lot more complicated ones, but that's the easiest function. Vertex of an absolute value graph is the highest or lowest point on the graph of the absolute value. It'll be the corner of the graph. So in this graph it would be right here, and then in that graph it would be right here, the vertex. Transformation. Transformation changes a graph's size, shape, position, or orientation. P-O-N. Ran out of room here. All right. Translation shifts a graph's horizontally or vertically but does not change its size, shape, orientation, all that stuff above. Shape, size, orientation. A reflection is when a equals -1 and you have a graph y equals a to the x. And that's a reflection in the x-axis. So reflection in x-axis. So it acts like the x-axis is a mirror and it reflects the graph. Parent function for absolute value functions. The graph of y equals absolute value of x is V-shaped. And is symmetric about the y-axis. So for every point xy on the graph, the point negative xy is also on the graph. The highest or lowest point in the graph of an absolute value function is called the vertex. The vertex of the graph y equals absolute value x is 0, 0. Okay, I'm not going to fill in all of this box. What you need to know for that box is if you have y equals a times absolute value of x, depending on what value I can put here in the a, it can stretch or narrow the graph. So kind of be aware of that when you see an a there. It'll make it look a little different. So let's just look at an example of that. Example 1, graph this function. So y equals 1/3 x. And then by equals -2 times the absolute value of x. All right. They made a typo error in here. It should be the absolute value here. So let's go ahead and make a XY chart, which they don't do it this way, but This is a nice way to do it. If I put 0 in for x, what am I going to get out? 0 for y. If I put 1 in for x, what am I going to get out? 1 times a third is a third. If I put a negative 1 for x, then the absolute value negative 1 is positive 1, and again, 1 times a third is a third. So let's see how this graph is going to come. So 0, 0, and then if I go across to 1, and then up to a third, and then I go across to negative 1 and up to a third. So it's going to look something like that. Each point will have a mirror image. Okay, on B, let's again put a XY box for this. So XY. If I put 0 in for x, I'll get 0 out for y. If I put 1 in for x, I'll get negative 2. Put negative 1, I'll still have negative 2. So if I graph this, 0, 0 again, and then 1, negative 2, negative 1, negative 2. It goes down this way. Notice that it's a reflection of what we usually see, because this A is negative. So the negative sign on A flips it upside down. Checkpoint. Go ahead and graph this by making an XY box. Make sure that you pick some positive and negative values for x. So I would pick 0, plus 1, minus 1, and then to just check yourself once you pick 2. And then go ahead and graph this and see what it looks like. Is it pointed up or down? It'll be pointed up because this is positive. Okay, example 2. Graph a function of the form. Now, in this form, H and K are the vertex. But notice that we have to have a negative sign there and we have to have a positive sign there. And if we don't, we need to change it so we don't change the value, but we actually put a negative sign in front of it. So let's just see how that is done. So up here, can we pull off our vertex straight off this? No, because we need a negative sign for this positive sign here. But we know that a minus minus is also a plus. So I can change that to look like this. Y equals negative 3, x minus a negative 1, or negative 2, sorry. And then I need a plus sign there. But we know that plus a negative 1 would still equal minus 1. Now I can pull my h and k straight off. So my h is negative 2, and my k is negative 1. That's the vertex. So negative 2, negative 1. Now, I'm going to plot another point on this graph, and it really doesn't matter where. I'm going to choose a convenient number to plug in for x. Do you see up here that a very convenient number for x would be negative 2? And why is that convenient? It's because negative 2 plus 2 is 0. So this whole term would be 0, and then y right away is negative 1. So I don't have to do a lot of math with that one. Uh-oh, that's my vertex. So that's not going to work, is it? Let's go ahead and go up to negative 3. So negative 3 plus 2 would be negative 1. The absolute value of negative 1 is positive 1. Positive 1 times negative 3 is negative 3. Negative 3 minus 1 is negative 4. So if I put in a negative 3, I'm going to get a negative 4 out. 1, 2, 3, 1, 2, 3, 4. Okay. Now I know that I have a symmetrical side of this, so all I need to do is go ahead and draw the other side in, and this would be another point in my graph. So the point negative 1, negative 4 is a symmetrical point. Now I need to connect the points with the V-shaped graph, which I just did. Let me go ahead and carry it on out. And now compare that with the graph y equals x, the absolute value of x. If I draw in the parent function for this, it would be like this. Do you see how this is, this one is squished together and it's flipped upside down. And remember why it's flipped upside down is because of up here, this negative 3 in front of it. Okay, if I have an absolute value graph and I want to go back to the equation, I need to look at the vertex first. Vertex is 3 and 2. So I can put that in my standard equation. Y equals a times absolute value of x minus 3 plus 2. Remember, I had to draw this standard equation with the minus here and the plus here. The signs are very important. Now I'm going to substitute the coordinates of the point, any point that lies on this graph, in a nice place. You want to use this point because it would be hard to read off what it was. So I'm going to use the point negative 1, negative 2, or positive 1, sorry, negative 2. And then I'm going to go ahead and solve that for a. So y, what's my y? Would be the negative 2 equals a times x, which is 1. And I'm going to stick this minus 3 right here, and stick this plus 2 right here. So now coming this way, negative 2 equals a. What's the absolute value of 1 minus 3? 1 minus 3 is negative 2. 2. And then negative 2 equals a. Absolute value of negative 2 is positive 2 plus 2. Subtract 2 from both sides. So go ahead and move this up. Minus 2 minus 2. I have negative 4. Flip this around so I can see it better. Equals 2a. Divide by 2. So a equals negative 2. Now that's not my answer. That's just my a value. So I need to substitute my a value back into the form of my graph up here. So my whole answer will be y equals negative 2 times absolute value of this x minus 3 plus 2. And that's my equation for that graph. Checkpoint. Complete the following exercises. Graph this function. Okay, first pull out your h and k to find your vertex. So your vertex will be the ordered pair hk. You need to make sure that your signs are right. So is this sign right? Yes. That sign's right. I can just pull off the h straight off. Is this sign right? No, it needs to be a positive. So I need to rewrite that as plus a negative 2. And then I can pull off my k as being the negative 2. So plot that point as your vertex, and then pick a point or two, and remember that it's going to be a V-shaped graph because it's a negative out front of here. It'll be upside down. Okay. Next one, we're going to write the equation of that graph. And your HK is negative 1, 3. So you're going to write your standard form. Y equals A x minus h plus k. You're going to put in negative 1 for your h. Remember to put in parentheses, because you'll actually clean up those signs and say that's x plus 1. And then you're going to put your 3 for your k. Next, substitute negative 3 in for x here, and 7 in for your y, and solve for a. So we need a equals something. Then take that value of a and put it back into your equation with your h and k. Okay, we're not going to finish this note set, so just go ahead and leave this blank. We may get around to talking about this in class.